Assalamu alaikum. My name is Umar Baskar. Our presentation topic is linear programming in graphical method. Uh, First of all, I will discuss what is linear programming. A statistical method of allocating resources limited to achieving objective. Linear programming is a method of performing a specific goal functions depending on the equilibrium and the constraint of direct inequality. Linear programming is a technique for optimization of a linear objective function subject to linear equality and inequality constant. Line planning determines how best to achieve the best outcome in a given mathematical model and is given a specific list of needs represented as a direct calculation. A linear programming model seeks to maximize or minimize a linear function subject to a set of linear constants. There are two main methods of linear programming. First, maximization of profit, and secondly, minimization of cost. There are four main components of linear models. A set of decision variables. The decision variables are variables that will decide may output uh, they represent my ultimate solution. To solve any problems, we first need to identify the decision variables. Secondly, an objective function. It is defined as the objective of making decision the company wishes to increase the total profit. Profit is my objective function. The second is a set of constant. The constant or the restrictions or limitations on the decision variable, they usually limit the value of the decision variables. In example, the limit and the availability of resources, milk, are my constant. The last one is non-negativity restrictions. Uh, for all linear programs, the decision variables should always uh, take non-negativity values. This means the value of decision variables should be greater than or equal to 0. Linear programming in graphical methods. The graphical method is used to optimize the two variables linear programming. If the problem has two decision variables, a graphical method is the best method to find the optimal solutions. In this method, the set of inequalities are subject to constant. When there are two decision variables, plot the constant equations and their limit by converting each equations to an equality. Identify the feasible solution space, the create an isoprofit line based on the objective function. Linear programming application. First, schedule school buses to minimize total distance traveling. So whenever you involved in some transportation process, this method will be very helpful in defining the different transportation route. The cost of transportation may be minimized. Second, allocating police patrol unit to high crime areas in order to minimize response time. In every organization, all the managers are interested to minimize the transport time to certain requirement. So of course, linear programming be very helpful achieving the particular objectives. Third, arranging forecast for bank to meet the need of the each hours of the day while reducing total staff cost. It guides us to maximize the profit through the limited resources that may be machinery resources and the labor resources. So through this method of linear programming will be available achieve their objective minimum possible times and with the optimum utilization. Fourth one, the selecting a factory product mix to make the best use of machine and working hour while receiving company profit. It can help you find out the use different raw materials which can be used in production of the final product and final product and services through which we can maximize profit or the cost of the production will be minimized. Uh, by picking a blend of raw material in feed mills to produce finished feed combination at minimum cost. Sixth one, the determining the distribution system that will minimize total shipping cost. We can have some optimum solution for production or inventory in order to maximize the profit and minimize the cost of productions. Seventh, manufacturing industries use linear programming for analyzing their supply chain operations. Their motive is to maximize efficiency with minimum operations cost. As per the recommendation from the linear programming model, the manufacturer can recognize their storage layout, adjust their workforce, and reduce their bottleneck. The second last one, the optimization is also used for optimizing delivery routes. This is an extension of the popular traveler salesman problem. Their service industry use optimization, finding the best route for multiple salesmen or in multiple cities. With the help of clustering and greedy algorithm, the delivery routes are decided by companies like Amazon, etc. The objective is to minimize the operation cost and time. Last one, the optimization also used in machine learning. Supervised learning work on the fundamental of linear programming. A system is trained to fit on a mathematical models of a function from a labeled input data that can predict values from an unknown test data. Requirement of an linear programming problem. There should be an objective function to maximize or minimize some quantity, usually profit or cost. The restrictions or constraint are present which limit the ability to achieve objective. There must be alternative course of action from which to choose. The objective and constraint on the problem of a coherent system should be expressed in terms of equality or inequality. Formulation of linear programming problem. There are four steps of formulating a linear programming problem. Step 1, identify the number of decision variable which given the behavior of the objective function. Step 2, identify the set of constant on the decision variable and express them in the form of linear equations or inequations. This will set up the region in the dimensional space within which is the objective function need to optimize. Don't forget to impose the condition of non-negativity on the decision variables. All of them must be positive since the problem must represent a physical scenario and such variable cannot be negative. The second last one, the express the objective function in the form of a linear equations and decision variable. Step 4 and last one, optimize the objective function either graphically or mathematically. Uh, my portion is over. The next portion will be discussed. Sayed only.
Sir, my name is Sayedowati and illustration and examples of maximization and minimization process for the linear programming. First of all, I would like to elaborate an example, which is the example of a maximization process. Here is the example. Department produces two product A and B. Both products are produced on the same machine. This is the table given for machine X and product X, A and product B. Time or minutes available for machines or machine W is equal to 66 minutes and machine X is equal to 140 minutes. Expected profit on product A and B is rupees 16 and respectively calculate the number of units of product A and B. Department should produce to maximize the profit. Here we have to calculate the total number of products A and B that the department will produce to maximize the process. We will change all these inequalities into equality. First, as given above, we have an expected profit of product A is equal to 16, product B is equal to 12. First of all, we will suppose these products, we will suppose two constants which is X and Y. Now we will change these constants which is into equalities, that is Z is equal to 16 and Y, which is the expected profit. Then above we have two equation which is 2x plus 6y which is smaller than equal to 66 and the second equation is 8x plus 4y which is smaller than equal to 1. Now one for here we will solve for line 1 and also for line 2. We can say also say that all these equation 1 and equation 2. For equation 1, first we will intercept y and put the value of x is equal to 4 in order to calculate the value of y. Here we have calculated the value of y which is equal to 11. Similarly, for the same equation, we will intercept x-axis and putting the value of y is equal to 0. After that, we will get the value of x. Similarly, we do the same process for the equation 2 and we will get the value of x and get the value of x and value of y. After that, we will put all these values graphical representation. We will draw a graph on x-axis and y-axis and put all these values on x-axis and y-axis. After putting all these values, we will get this graph. Here, line 1 and line 2 intersects on point B. The point of this intersection is called B and value of this B can be calculated after that. We will calculate the value of B after that. First, we will putting all the values from the equation 1. We will put the value of x is equal to 0 and y is equal to 11, which is given as. And this point is known as point A. Now, from point 2, we will put the value of x is equal to 15 and y is equal to 0. This point, this point is called point C. Similarly, from equation 2, we will put the value of x is equal to 30, 0 and y is equal to 30. And similarly, from point 2, equation 2 will put the value of x is equal to 33 and y is equal to 0. This is the line 2 and this is the line 1. And this whole area is a feasible region and this feasible region is known as, say that this is the 0, origin is O, B and C. This is the graph or this is a triangle which is normal and we will highlight this. After that we will find the value of coordinate B. In order to find the value of coordinate B, we need to solve the equation 1 and equation 2. In order to solve the equation 1 and equation 2, first we have to multiply the equation 1 by 4 in order to get the same value. After getting the same value, we will cancel out. Here we will get the value of y which is equal to 7.2. Now putting this value of y in equation 1 in order to get the value of x. After that we will get the value of coordinate B. Equation in the example illustrated above, he said that also find the corner points. For finding the corner points, we have the expected point which is z, and corner points that we have all available. Which are corner points are O, A, B, and C, and we have values of all these points as given as follows, and we put all these values in the expected point which is z is equal to 16x plus 12. Putting the value of x and y in this, will get the corner point O is equal to 0, A is equal to 132, B 68.8 and C is equal to 240. After that, the maximization process is complete. Now I will illustrate another example, which is the example of a minimization process. In the minimization process, let me first illustrate the example. Read out it. City Queen nurse manufactured bags for potting soil for the compost and the topsoil. Each cubic foot for the compost sand and contains 4 pounds of sand, 3 pounds of clay, and 5 pounds of humus. Each cubic foot of topsoil consists costs 20 cents and contains 3 pounds of sand, 6 pounds of clay, and 12 pounds of humus. Each bag of potting soil must contain at least 12 pounds of sand, at least 12 pounds of clay, and at least 10 pounds of humus. Plot the constraints and identify the feasible region graphically or with corner points. Find the best combination of compost and soil that meets the stated condition at the lowest cost per bag. Identify the lowest cost. Here we will have this process. In order to find the lowest cost, we will first generate the all we will make an table of the account statement, which is a sand, clay and humus and compost, topsoil and nitrogen. Now, that compost, now we will suppose compost is equal to x and topsoil is equal to y. Now, changing all these inequalities into equalities, we have the compost is equal to x and topsoil is equal to y. And we have to find the best combination and we have an equation which is C is equal to 0.12x plus 0.2. Now 4x plus 3y is greater than equal to 12. This is called equation 1. After that, we will solve the equation 1, 2, and 3. We are solving this equation in order to get the value of x and the value of y, which we have first from equation 1. We will get the value of x and value of y. In order to get the value of y, we will in y intercept and putting the value of x in y. Similarly, by to get the value of x, we will intercept x and y is equal to 0. We will get the value of x is equal to 3. From line we will get the value two values, which is x values and y values. For line 2, we will again repeat the whole process and put the value of x is equal to 0 and get the value of y is equal to 2. Similarly, for a similar process for the line 3, we will get the value of y is equal to 0.803 and we'll get the value of. Now, putting all this above value, before putting all this above value, we will draw a graph of x axis and y axis and putting all these values of equation 1 and equation 2, we have to equation 2 and we will put all these values over the x axis and y axis. When we put the values, when we put the value of line 1, we'll get 0 and 4, that is 0 on the origin point because x on the x axis is 0 and on y axis it is 4. On y axis, similarly on x axis it is 4 and on y axis it is 0. After putting all these values, we'll get a certain point where line 1 and line 2 intercepts. The intersection point is known as coordinate P, the value of which can be determined. After finding all these, we will have a origin which is known as O, A, B, and C. Now, after that, we will highlight the above area because this is only after that, we will find the value of coordinate B. In order to find the coordinate value of B, we will solve the equation 1 and equation 2. In order to do this, we will multiply equation 1 by 2 to solve this. We are multiplying this equation in order to subtract equation 1 from equation 2. When we subtract in for equation 1 from equation 2, we will get 5x is equal to 2, x is equal to 2 and 4. When we get the value of x, we will put this value of x is equal to 0.4 in equation 1 in order to get the value of y, which is y is equal to 0. This is the value of coordinate b, which is 2.4 and 0. In the example, they say that to find the corner points. For to finding the corner points, we have corner points A, B, and C, and we have types of products, which is compost and soil, which we have assumed as compost is equal to x and topsoil is equal to y, and we have equation which is x c is equal to 0.2y x plus 0.2y. So on A we have value of x equal to 0, and on y we have value of y is equal to 4. We have value of B and C on putting the value of A x-axis and y-axis on the equation we will get onside equal to 0.8, corner point we get 0.8, and the corner point for B we get 0.448, and corner point for C we get 0.48. After the whole this minimization process, the required condition is met. So this is the minimization process of the graphical representation of the linear program.